Hey everybody, welcome back. We're going to talk about a piston's best friend, the connecting rod now. So connecting rods and diesel engines are mostly all cross-sectional I-beam designs. You can see a little bit of what I mean there as far as I-beam goes, similar to a steel beam. Some I-beams are a little more pronounced than others. You can see that's a little Yamaha rod there. So this connecting rod is what transfers the motion of the up and down of the piston to the rotational at the crankshaft here. The crankshaft journal that goes through this is called the crank pin. You've got a bearing in here, and you've got a rod cap of approximately a 45-degree angle here. So you can see your seam there and there. So that anywhere from 45 to about 60 degrees are the two options usually. So what would the purpose of having your rod cap sit at an angle like that be versus straight like that? Well, you can get a lot more material and a lot more strength if you have a bigger end than this little guy. This little guy with a straight 90-degree split, you need a cylinder that is just over 2.5 inches, and you've got a cylinder that is about 2 3/4 inches. So you would have no problem dropping that rod down through that cylinder. This guy, on the other hand, if you measure the cap itself this way, you're at about 4.5 inches. Well, this piston is just under 4 inches. So you would never be able to get this cap, if it was cut squarely there, down through that cylinder. You'd never be able to get this in and out of that engine. Because they cut them at an angle, let's pull this cap off so you can see what I really am talking about here. Because it's cut at an angle, if you measure straight across that, you're at a little under 4 inches. You can actually drop that down through that cylinder. Again, if that rod cap was cut squarely, it's too wide. You wouldn't be able to do it. The cap would be wider than the piston. It would never fit. So these are all machine cut rods. They're cut and then polished. After they're cut and polished, they're reassembled, clamped down, and then this bore is precisely machined. You've got your bearings here, the rear surface, which should never have any oil on it here, nor here when you assemble it. That's how you spin a bearing. They should all have some kind of indexing tab so that you can't install them backwards or upside down. If they're the identical bearing, the same on the top and the same on the bottom, then the index tab may be in the same place. Not all bearings are the same top and bottom. Some say specifically on them top and some say specifically on them bottom, and that's all due to the material, the composition of that bearing. So that's going to determine where your indexing tab goes. Most rods are designed so that you cannot put them together backwards. However, you should always pay close attention to the way you disassemble them because they must go back together in that same fashion. Because remember, they're machined to an exact circular tolerance. If they machine it perfectly this way and you put that cap on backwards, you may not have a perfect circle anymore. You'll lose your tolerance. Again, you can spin your bearing or seize your engine. If you've got an engine in a straight configuration, like a straight 6, both sides of the rods may be close to identical. That doesn't mean that there's not a front and a back to the rod. You should always read your manufacturer's manual. If you've got a V engine then that means one side of the rod is going to be a square cut polish, because in a V configuration, the rods share the same journals. So you would have another rod rotating around right next to this one, going the other way if this one's going that way. The side against your crank is going to be chamfered. So if you put these together backwards, again, you're going to be pinching those together. You're going to be drastically increasing friction and real quickly heating something up and potentially seizing your engine. You can see how hot this thing got. So those were both machine cut rods. The latest and greatest is your fracture split, or your split fracture, depending upon which way you want to say it. These rod caps are actually broken off of the rest of the rod. So what they do in manufacture, they end up laser etching or scribing where they want it to break, and then they assemble the rod is, still one piece, and in its press, they hydraulically press a die down in there that starts spreading and spreading until it actually fractures off this part of the cap from the rest of the rod. That now means this cap can only go onto that rod one way in a perfect formation. All that grain is going to make sure that that rod goes on perfectly. In addition to that, you need to make sure that you don't put it on backwards, or that it's not slumped off to one side or the other just a little bit when you're torquing those bolts down. They need to be precise. You also need to be extra careful with these, because as soon as you dent one of these surfaces here, that rod is now junk and it needs to be replaced. So you shouldn't ever leave this rod laying on a table like that, because even just the weight of the rod can end up deforming this fracture. Anytime these are removed, you should then reassemble the rod on the bench and snug these bolts into place to prevent any damage to this surface. Like I say, a fracture split is the most common rod in use now. They're going to be laser etched or scribed, then hydraulically wedged apart. They're also 17% lighter, and they're more economical to produce because there's less steps to manufacturing. You're not cutting, rebolting, polishing. You can have this thing all the way done and then fracture split it. But like I say, if damaged, they are junk.